Today, we have the honor to have with us Mr. Mileounis and Mr. Georgopoulos from Accenture. We're delighted to hear their experiences in getting machine learning to the customers of Accenture and what this may entail. We're really glad to have you with us. Please try to leave some time at the end for discussion. I would say, if possible, let's take 30 minutes for the presentation and then have another 25 minutes for discussion. Is that okay?
That's fine. Thank you.
So the floor is yours.
Okay. Welcome to everyone, and thank you for having us today. Just give me a minute to go ahead and share my screen. Okay, would like to thank you once more for having us here. Actually, when we meet people like this group, it reminds us of when we used to be in academia. And this is a particular important to us because all the areas in which you do research on, we apply them in order to solve real-life problems. Today, we'll be discussing the frameworks that we follow to solve data-driven problems and also to give you some examples. So let us get started with introductions, who we are and what is our background. As for myself, I spent 10 years in academia, upskilling myself in the UK and then returned back to Greece in the University of Athens to do my PhD degree and also my postdoc. Post my research in signal processing and machine learning, I moved on to the industry where I'm currently based for the last 10 years. Right now, I'm an ML engineering principal director at Accenture's practice that is based in Greece. Andreas, if you can give us a short intro of yourself.
Absolutely. Hello, everyone from my side. This is Andreas. First and foremost, it's a pleasure to be with you all today. So a little bit of my background. I'm a mechanical engineering principal, studied in the National Technical University of Athens, then moved to the UK to pursue my master's in business analytics and data science at Imperial College. I'm working with Accenture the last almost 5 years, currently as a machine learning engineering manager with a functional expertise in AI, machine learning and automation. And industry, I would say high tech and a little bit of energy. So pleasure and thank you for having us here. Gerasimos, back to you.
Okay, thank you, Andreas. So let's get to know each other, who we are. So Accenture is a global consulting service company with leading capabilities in digital, cloud, and security. We combine experience and specialized skills across more than 16 different industries, and we offer strategy and consulting, interactive technology, and operation services. Our work home for Andreas and myself is a subdivision of strategy and consulting that is known as Applied Intelligence, and we'll be discussing it shortly. Our 624,000 people deliver on the promise of technology and human intelligence, serving clients in more than 52 countries. We embrace the power to create value and share success for our clients, people, stakeholders, partners, and communities. Let's double click on our capability group, which is called Applied Intelligence. Applied Intelligence defines how Accenture uses automation, analytics, and artificial intelligence and the data that fuels it all in order to power every single customer and every single process to deliver 360 value at speed and at scale. At this point, some of you may wonder how we partner with our clients. We do have a collection of AI solutions that act as accelerators. And of course, we do have flexible partnership models that could either be a fixed fee investment for a deliverable, as a service to go build a product, or based on the outcomes of our work. Continuing on, we operate with innovation at the heart in whatever we do. And actually in Greece, we have the pleasure to host one of the 25 centers of excellence that demonstrate and reuse innovation of use cases and assets across more than 16 industries, as well as, of course, doing and serving client delivery work. Our global delivery models allows delivery at speed and from several locations. So let's showcase to you what's the DNA of our Center of Excellence. We do have a long-lasting experience on customer pricing, marketing, and sales analytics, serving hundreds of clients across the world from multiple industries. The team structure is composed of 140 people with a multidisciplinary background that spans from engineering, computer science, physics, maths, and economics. We also imagine and invent on the future of our clients by shaping assets that will help them in the near future. Now, the technology footprint has become really wider on the data space. For that reason, we have grouped our people on three different categories. Those who use data science to analyze data, produce insights, and deploy those in production, the people who are responsible for the collection, transformation, and architecture of data platforms, and those who advise on the strategy that our clients need to follow in order to become a data-driven organization, as well as identify what is the value of the client's data. Continuing on, we would like to share with you how we think of artificial intelligence. We think of it as a set of tools and technologies that tries to mimic the human senses. We are using machine learning for learning purposes, where over there we are training models that are able to adapt and generate predictions in the future. NLP to be able to communicate with human in with several languages, speech for being able to interact with humans, computer vision in order to understand images, video sources, and extract knowledge, and of course, robotics for interacting in the form of robotic process automation, as well as virtual agents. In the next section of our presentations, we would like to showcase to you some of the high-tech industry trends. So let's get started with those trends. We'll not double click in all of them at the interest of time, but what we could say is that we are seeing three different areas: technology, business, and customer trends. If I had to highlight the key ones for this group, those would be IT modernization for scalable CPU and GPU architectures, 5G edge computing, allowing low latency operations with all the terminals, AI/ML for services and marketing organizations, and computer vision for manufacturing quality operations. Now, let's see the technology of evolution and discuss it a little bit briefly. So the benefits of cloud technologies is something that is undoubtable. However, the pandemic period acted as an accelerator for its growth and adaptation to our clients. The evolution of Internet of Things, it helped us establish the artificial IoT that allows to improve the human-to-machine interaction via the enablement of wearables, smart home, smart city, and smart industries. The use of ML, it's actually helping us to create the customer 360 vision, establish services without physical presence and predictability features, something which is a booster on the operational efficiency of a high-tech industry. 5G edge computing are the enablers for augmented reality and virtual reality, as well as low latency between terminal devices, allowing to analyze in real time large volumes of data. Moving on the business side of things, there was an upgrade on the commercial model, similar to what Netflix and Spotify are doing, meaning as a service tech equipment for rent. Pandemic and geopolitical crisis actually affected heavily the production line. So there's no need for there's a need actually, apologies, for stabilization and to bridge that gap in case such events occur in the future. Continuing on, Andreas is going to be discussing how we're going to be industrializing the AI MLOps. Andreas, over to you.
Thank you very much. So Gerasimos just mentioned the need for tech evolution and op model reinvention. So what are the main challenges that prevent us or prevent an AI ML solution to scale? A well-defined large-scale data foundation with data being updated with accuracy and speed, reproducibility of the experiments when it comes to development and production environments, collaboration and reuse of applied solutions and techniques, the scalability, how from an offline implementation we will proceed to a wider scale application seamlessly and efficiency. Observability of the performance of an application or a model throughout its life cycle. We see a machine learning solution not as a one-off process, instead as a multivariate organization that evolves as all of its components will change over time. So we should be in a position to monitor its efficiency to proceed with the necessary corrective actions when needed. Last but not least, the way each organization controls access, sets policies, monitors ML applications, ensuring the necessary compliance with the rules and the policies. So moving to the next slide, let's double click on how we can utilize MLOps to bypass some of those challenges. Through standardized workflows, it is possible to reduce the cycle time, how much time is required for a solution to go into production. By managing the solution or the application or the versions, the historical versions of a machine learning model, we are able to increase trust and traceability of the results of the experiments that we're doing. Through a self-healing mechanism, in cases where a performance degradation or a model decay is observed, we are able to reduce the response time and the cost for maintaining an application. Through a monitoring system and with some well-defined deviation metrics, we will reassure the quality of a model to be maintained in the future. And finally, with some specific structures and well-defined procedures, once again, we can improve the business results, the benefits through the awareness and the realization of the value. Moving to the next slide, I would like us all together to take a step back to see the basic functionalities or conditions to apply AI ML at scale before we deep dive into the features of MLOps. Three basic components, pillars that we define as capabilities that work in parallel, in conjunction, and are all interdependent. We start with data ops. This is nothing more than a data supply chain, including data discovery, acquisition, curation, and provision. Second stop, MLOps, the production of the applications powered by machine learning and artificial intelligence practices. Third one, AI and ML experimentation, where we have continuous construction, testing, adjustment, and evaluation of the models and the services that we're developing. As Accenture, we have implemented an in-house industrialized ML framework, we call it IML, that integrates data operations, data exploration, and AI experimentation capabilities on cloud for enterprise level build, deployment, and management of AI application. So should we move to the next slide to discuss what MLOps is after all? We think of MLOps as the journey across the life cycle of one solution, of one application, starting from the design to the implementation and to the last step, which is the management of the solution. So we have three basic steps. We start always with a POV, the proof of value. This is where we are experimenting, we are defining the use case, we do the requirement gathering, we're hypothesizing on how we want to solve the solution, and then we start offline our typical, let's say, data science flow from feature engineering to model development, model evaluation, where we can prove the value and have the buy-in so that we can move to the second step, which is the productionization of the solution. And again, there we want to refine the architecture for the application, the end-to-end ML workflow pipeline design, we would like to integrate this solution to additional, let's say, business internal or external systems to showcase the real-life value. Quality, security, and legal are always there to reassure that the solution is ready to go live so that we can have our final end product ready for deployment. Do we stop there? We have a third step as well, which is the operationalization. What do we want to achieve here? We have deployed our application. However, we need to continuously monitor the application to proactively identify risks, issues, intervene to ensure that the performance will be there as defined by the end users, by the business. We want to incorporate the feedback that we are receiving to proceed with the necessary actions, and always introduce additional intelligence to our end-to-end process so that we can trigger an automated self-healing mechanism. So in the next slide, we will review an indicative MLOps pipeline. We will go through some of the basic steps, and we can double click if there's any question at a later stage. The first step is the algorithm template. We have to define what we want to achieve through the MLOps pipeline. What kind of models we want to have, what kind of pre-processing steps we would like to follow or at least evaluate, right? From scaling, transformation, imputation, what kind of model packages our solutions should take into consideration, define the pipeline so that we can move to the next step. First is the model development. Based on the problem, the use case that we want to solve, what kind of classification algorithms we want to take into consideration, what kind of regression algorithms, in case our problem fits into this category, we would like to take, again, into consideration. Whether we want to build a custom model, everything should fall under the model development stage. We will proceed with the hyperparameter tuning and optimization so that we can start our parallel experimentations. Multiple data scientists may work on the same use case, on the same project. So they should be in a position to utilize the same template, utilize and explore different machine learning models. And as a baseline, they should be in a position to evaluate on the same level. That's why we have the next step without being the model validation. We need to define how we will train, how we will evaluate our training, validation, test data sets, our results, so that we can have a baseline and have this inbuilt feature within the pipeline. Model security is always there and should always be there for the MLOps through authentication and encryption of the frameworks through CI/CD pipelines with security layers included. Model management when it comes to metadata, versioning, registry, how we will tag the model and the data after all, so that we can end up with our final step without being model monitoring. We discussed that and we will double click on this one in a bit, but as of now, we need to be in a position to showcase insights, monitor the model performance, and intervene where needed. So in the next slide, we will define the flow of the pipelines. We start with the development or the experimentation pipeline, where all data scientists build a model or a solution. Includes all the steps that we follow in an offline development, from data processing, model exploration, optimization, training, evaluation, even post-processing of the results. We continue with the packaging of the model that will lead to the inference pipeline, which is the second step. In other words, the production pipeline. This is nothing more but the application that integrates into other systems and gives live predictions on unseen data that may flow into the ecosystem. At this point, there is a continuous monitoring of the performance of the solution and all of its components in order to activate the self-healing mechanism in case of deviations or risk, ending up with the third and last retraining pipeline, following all the standardized steps of the template that we defined in the previous view. At the bottom of the page, you can see some typical tools that can be used in different stages to the MLOps pipeline, from Git, for example, for code versioning, Python for your core or ML development, software engineering and DevOps tools for CI/CD, packaging and application hosting, MLOps open source tools, and some cloud providers. In the next slide, we will discuss the observability and the insights components. At the beginning of our discussions, we defined as a key dimension of our MLOps pipeline the ability to continuously monitor and observe the performance of the solution. In a machine learning model, the basic metrics that we monitor, and I think we all agree are necessary, relate to the performance per se. Its predictive abilities such as accuracy, recall, precision in classification problems, or mean or root mean squared errors, absolute errors in regression. Are those enough? The answer is no. We need to define additional metrics to cover the stability of the model as well. Those are the stability metrics that we have defined in this view, and will give insights, for example, when we have potential statistical shifts, drifts of the distributions between the training and the live data. The reason, if the historical distribution of a variable has deviations, then the reality that the model was previously trained on and knew as a baseline has changed. So we'll have to retrain in the new data. In the last bucket, we see operational metrics, which are also necessary since we're talking about applications, microservices. So some indicative examples: the pipeline execution times and the resource allocation. Infrastructure restrictions are always there for everyone. Proxies for system health status, training versus prediction. Another metric, dependencies change frequency. The data version change. We have source system or side packages or environments that have to be upgraded. We need to track that. Why? This might cause some breaks in our pipeline, so we may have to do some side refinements. Model decay, the monitoring performance that we discussed to enable preventive and non-reactive actions. And we can be very creative here when it comes to how we want to evaluate our model, how we want to evaluate our application, iterating with both technical and business audience so that everyone is confident on the why and how of the solution observability. So in the next two slides, we have some referential mapping. We will not deep dive into the details for the interest of time. We just wanted to showcase to you some three main cloud providers, essentially, providing end-to-end MLOps capabilities, as well as some non-free platforms. And in the next slide, some open source tools that someone can start exploring, experimenting in the current data science project that you are working on. For example, MLflow, Metaflow, Kubeflow, all of those are a good starting point so that you can start exploring. And again, one last comment on my side, those are not, it's not an exhaustive list as a starting point, nor we're showcasing the best when it comes to performance or ease of use. This is just a good starting point for us all to start introducing MLOps practices in our current project. So I will hand over back to Gerasimos to continue our discussion with the last item of today's agenda, an interesting real-life use case. So Gerasimos, back to you.
Okay, thank you, Andreas, for walking us through the MLOps framework and how essentially we applied it. Having established that, what we would like to discuss for the rest of our discussion is one particular use case that such frameworks actually go ahead and find applicability. The use case that we'll be discussing, it's known as knowledge graph, and it can be used in order to tackle master data management challenges. We'll start with a definition of a knowledge graph, which is a data representation of knowledge domain as well as artifacts. We would like to think of it as a collection of references to your organization assets, content, and data that leverage a data model to describe customers, places, and things, and how all those things, they are interrelated. Question that you may have at this point is why we need a knowledge graph. Simply because it allows you to discover facts and relationships through inference, something that would be very tricky to catch in a relational model. It can also identify information that have a sparse structure and sometimes they are not interconnected. We will be continuing on and examine some of the business problems that knowledge graphs should be able to answer, one of which is known as entity resolution. A customer could appear multiple times within the same database. due to typos, name changes, aggregation across different systems, and so on. Entity resolution helps us get to the truth. I would like you to think of it as an intelligent data quality tool that allows to reveal the full customer view. Multiple entities share the same attributes, so they can be linked together by the knowledge graph. How we do that? Let's walk you through the steps that some of the algorithms are actually undertaking. We start with the extraction of the data from the source systems. Then we proceed and we apply text processing rules in the form of lemmatization, removal of punctuation, converting to lowercase, so on and so forth. Then we group together entities that are marked as similar for dimensionality reduction purposes, and then we try to find associations between all the reduced set of pairs across several domains that exist within an entity. And those are the name, address information, assets that they own, so on and so forth. Having done that, we would like to reconstruct the associated entries into a single matched entity. So once we have established that, the next step will be to proceed and store the clean version back to our source system. We will be showcasing to you another data challenge that we are seeing in MDM systems, where we are observing several records that are not tagged properly, and hence we would like to establish a process that allows to associate missing information with other tags in order to impute the missing content. For that purpose, we leverage a powerful AI-driven web crawlers that increase the number of sources in order to retrieve valid data from. So we are querying internet search engines like Google, Bing, LinkedIn, and others, and the information retrieved need to be automatically evaluated via machine learning models, and then either auto-accept the recommendation or skip that. This way, we are saving hours from a time-consuming process. We are doing it consistently and at scale. And we are saving hours of manual work from the organizations that are performing such actions and activities manually today. How we are deploying all those processes, we are following a continuous integration and continuous development, deployment strategy in order to automate the stages of the development. This allows us to integrate the code much easier, find bugs before actually they are released. We start with a sample workflow like the one that is shown here using stage branches. We first test the code with other features and components. If the build breaks, it goes back to the developers to fix it. If everything's fine, then the code is ready to continue to the next staging area where a full code base is ready to run and then eventually deployed. So that's a short overview of one of the use cases. And at this point, would like to thank you very much for your attention. And we hope with some of you will have the opportunity to meet again soon, because in the picture of this slide, you see our offices in Athens. Right now, we are very proud since our team is growing. Hence, you may find more information on our open positions. Those are posted on our LinkedIn channel, Accenture Greece, and share your CV through our recruitment email alias. So would like to open up our discussion for questions and answers.
Thank you very much. Thank you both of you for the very interesting presentation. Thank you also for doing it in a very concise way so that we have time to discuss. For the whole audience, everybody who's listening, you can either write your questions in the chat, and then I will transfer them, or you can choose to switch your mic on and ask a question. I don't see any questions so far in the chat. I have a few questions. Though I have several questions actually, but I will try to prioritize them. One of the questions that I have is how important is it for the customers of Accenture to be able to understand what the reason for a decision that a machine learning, a possibly complex machine learning model takes? The whole area of explainability that is discussed.
This is a very good comment, because we are seeing clients and people within the organizations to which we are working on. So being able to have machine learning models that allow explainability, it actually helps them to accept the recommendations of which we are making. So explainability definitely helps to have all those models being widely applied by the business, because the business are not people who are aware of the high accuracy that all the modern algorithms can achieve those days. So we need to bridge those gaps. We need to bridge that gap. Andreas, I don't know if you would like to add to this one.
Yes, thank you very much. Two quick comments on my side on this one. The very first one, why it's super important, and I totally agree with both of you, is to build also trust to the end users. If you understand the basic components, let's say, not the machine learning and how, let's say, we're training or how we're providing those predictions, but what are the key, let's say, drivers of one prediction, then the end consumer, the business as well, can relate to that, realize the value, and gain a little bit more trust. So that's the first comment. And the second one, it's really important to understand the output of a machine learning model to take the respective proactive actions. It's not a black box that we give a prediction and then nothing else is taking place. This should be integrated into, let's say, an enterprise tool, or should drive, let's say, data-driven decision-making or additional proactive actions for the business. So the explainability will give this flavor, if you'd like, or this nature to take the next step, instead of having one black box tool that gives some good probabilities or a good clustering solution, right? We want the business to take that and integrate that in their, let's say, day-to-day work, or even in their DNA, right? So that they can start shifting into a data-driven decision-making overall. So those were the two comments that I would like to add.
Can I just take that one step further? So given the importance of explainability and the difficulty at the same time of having explainable machine learning these days, how do you deal with it? I mean, how do you provide the insight that you talked about to the customer regarding the decisions made by the machine learning systems?
If I had to make, let me try to answer this one through an example. Let's say that we have a classifier model, a binary classifier model. So we have a set of features that some of them will be voting towards a yes and some others against a no. So being able to have the trustworthiness and the full transparency to the client around what are the data drivers that are driving towards a yes, that helps them understand what is happening behind the scenes. And because we're having people that are, let's say, from the business, they will be able to relate and get trust to those recommendations. So that's one way of achieving that.
But if you have a very deep model, how can you identify those drivers? That's my question.
We could do that two ways. We can either try to have a model that allows explainability, or on top, build another model that will reveal the explainability.
Okay. Which one do you usually prefer when you're in your projects?
We're trying both, and depends. Depends on where we are with, let's say, the model that has explainability, and we take it from there. We do not have a fixed strategy around it.
And also, if you allow me, Gerasimos, to add, it also depends on the maturity of the client when we're talking about AI, machine learning as well. So it's completely different if we're talking about a super mature or super high-tech organization compared to someone that wants to start exploring this space. So in the latter, you may start small with a simpler, let's say, model that everyone can relate to, that will provide, let's say, easily explainable, let's say, outcomes, and then move into more advanced implementations.
Okay, thank you. There are a few questions now in the chat. I will start with the first one, which is a question from Dimitris about the training that one needs regarding machine learning, but also specifically for MLOps. There's a question of whether Accenture would hire somebody who has training from Coursera, online courses, Udemy, etc.
The answer is yes. And actually, we have people and we hire people who are either experienced or they are just starting their journey on this space. And one of the great things working for Accenture is that every single one of us, they have a dedicated training path aligned to the capabilities that we are working. So every single year, depending on the latest state-of-the-art achievements, we are updating our training path depending on the maturity of each individual.
And there's another question about training and hiring. There's a question of whether somebody could work for Accenture while doing in parallel a PhD.
Yes, we examine those cases on individual basis, but we have several colleagues of ours that they are working part-time or they started working full-time, then they are returning back to academia to refresh their skill set and then come back. So the answer is yes.
Okay. Then we get to more technical questions. Can you share more how you observe or detect prediction drifts?
Andreas, would you like to take this one?
100%. So when it comes to our, let's say, model performance, we handpick on live data, right? Think of that as a streamlined process where providing predictions on continuously on unseen data. We randomly should sample some of those live predictions to evaluate behind the scenes so that we can evaluate on unseen data how we're performing. So this is one case when it comes to our final predictions. Now, aside of that, we should also monitor each, let's say, KPI, each variable that we are utilizing for historical distribution drifts. Why this is important, as we mentioned before, what the model knows as, let's say, known, the actual, let's say, case for a variable, the distribution that we know now, this might change. So if what we know as our baseline is no longer applicable, then we need to trigger a self-healing mechanism to retrain the model so that training and unseen live data should come from, let's say, a similar background. Let's position it this way. So those are the two, let's say, main items for those shifts or drifts, how we identified them and how those should trigger the self-healing mechanism. Okay,
thank you. The next question is about tools that you use for MLOps. Are you using an open source tool or for your code base or several tools?
Again, this depends on the use case, on the client, whether we can use open source tools. For sure, we have explored, let's say, we start with the open source as a starting point always. No preference, or I don't know if the question was targeting with which one we should start, whether, for example, it should be MLOps or Kubeflow. I would propose to start exploring, let's say, one, and then you will see similar patterns in, let's say, the different options that you may have. But also, since we are working within clouds, and we have partnership with all cloud vendors, Amazon, Google, Azure, we are also implementing MLOps based on the available capabilities and functionalities that we have there. So open source as a starting point, based on client needs and licensing that we may have, we're also utilizing a lot of cloud providers.
And also, we are vendor agnostic. It really depends on each client and the strategic alliances that they have.
Can I just add to this, because I understand that you need to be flexible to your customers. At the same time, this makes it a bit harder for you, right? Because you need to switch and have many different options. How do you handle that?
In the difficult situation where it could not be, let's say, handled within one, let's say, vendor, then we are trying to use an orchestration layer in order to get the answers from another service provider and bring it back to the landing architecture. So do a little bit of a handshake till the maturity comes on the target platform that we are leveraging.
Okay. The next question is related to what I was talking about earlier, explainability. Do you prefer a particular explainability method like LIME, SHAP, or a different one? And why would that be?
Andreas, would you like to go first?
Yep. Well, again, SAP doesn't look as intuitive as LIME as a starting point, but this doesn't mean that we shouldn't try that. It provides summary charts that will make us understand an entire, let's say, ML model easily. So I would say use both. Use LIME to get a better understanding of a single prediction, and SAP for the summary plots, the dependency plots. If you have tried that, you may relate to what I'm talking about. Definitely use both, but I will definitely try to have SAP for sure, due to the additional, let's say, features that provides as output. But when it comes to, in general, data science, machine learning, we don't know what we want to utilize. No matter when we're talking about explainability, about training, about which model, we have to try that. And that's the art, right, of the science in the field that we're working on. So definitely try, not all of them, right, but some of your favorite ones, based on your experience or based on a previous use case that you have applied and you know that it worked really well. Give it a try. Be as open as possible. The exploration never ends, if you ask me, but you definitely need to have to set your base up to which you should continue to explore, so that you can start showcasing and realizing the value of your implementation. I don't know whether I covered the question, or you would like some more details on those, or Gerasimos, if you have anything else on your side you'd like to add.
I would like. Sorry, Gerasimos, you want to say something?
Just to add, so the choice of a tool or library that we're going to be leveraging, it also depends what will be the consumption layer that we're going to be passing those information. So as Andreas very well said, if we are mostly interested in having the summary plots, then we will not go with LIME. But if we would like to build something customized and we need raw information, then in those cases, LIME might be preferable. But in any case, I would agree 100% to Andreas' proposition to go ahead and try both.
I I'll take that one step further. Experimentation is obviously useful, especially when there are many options. But I find that one needs to have a very principled approach of how this experimentation happens, because you may get very different results. You may get very different intuition. How do you judge whether one should be trusted in favor of the other? Any ideas about that?
Mm-hmm. So, Gerasimos, do you want to pick this one?
I'll just start just by saying that sometimes algorithms may tend to give solutions which may not be business explainable. So using our, let's say, business knowledge, we'll assess which one actually makes sense. Because let's imagine that we have something that is a model with 52 features, giving a precision of 5% higher, and then having another model that only has 8 features with a slightly, let's say, degraded performance. We will prefer the one with the less features, and the rationale is simple, because it will allow the client just to make more targeted actions along a smaller set of data drivers.
I'm glad to hear that. I would also do the same, of course. But the more complex machine learning methods become, and we know how complex they are now, and the more choice you have, the more different methods or different architects or different parameters you have, I think that you may end up with many different results that are not easily comparable in terms of models, of parameters, of the number of features that you just mentioned, Gerasimos. So it seems to me very difficult and requiring a lot of knowledge and a principled approach in order to make sure that you're not basing your judgment, or you're not providing a solution that is not trustworthy, really. Do you agree?
I would agree, and I will add to that. Clearly, while training machine learning models, we have, or we are building grids where we are trying different set of models. Over there, while we are having those grids, we are also defining some business rules, because there are certain actions or recommendations that may come out of these models, which are not, let's say, business consumable. So our grids are actually embedding the algos as well as the business rules based on the knowledge that we have. And this way, we are reducing the dimension space where we are searching from, because this is important too.
That's interesting. There's one question about the life cycle of a project that you have. What are the responsibilities of a junior developer or another employee? And by junior, Gerasimos Vissarion means someone with a bachelor degree, but with no prior working experience.
Andreas, do you want to go first?
Sure, absolutely. So the life cycle of the project really depends. Accenture's goal is to have long-lasting relationships with their clients, right? So essentially, you may join a project that's ongoing for many years. However, you may have also an assignment that's starting now and will start again as a proof of concept, as a small one, let's say, that may have a duration, let's say, of 3 months. Or you can join an ongoing project, but you can easily rotate based on your preferences, needs, and the overall, let's say, team's expectations. Now, when it comes to the requirements for a junior developer, if I can quickly, let's say, describe your day in, day out, you will be part of an agile team as a starting point. You will not work offline independently. Instead, you will be part of a team. You will work all together to shape the solution, realize the value that we were discussing before, right? Push some offline experimentation into production so that we can build a scalable solution. So you will interact day in, day out with different data scientists, data engineers, additional colleagues that are supporting us to build the applications. So I don't know whether this covers, let's say, the nature of the question. I can proceed and share more details on this one, but in a nutshell, this is how, let's say, a typical day would look like.
Let's assume for the moment that it does answer the question. I have another question that is that has to do with the more fundamental aspects of AI in the solutions that you're building. Do you ever see the need for algorithms that are not already out there? Do you develop new algorithms, or do you feel the need for solving new problems with new algorithms?
That's a very nice question, and allow me to answer this one. I was, let's say, in a problem working for one of the largest banks in UK, where we tried to analyze data in a relational structure, and we are not able to meet the client's expectations from an accuracy standpoint. What we did, we had to be very creative, combine relational with graph structures all together in order to come up with a hybrid structure. This is something that we wrote up, and actually I hold a patent on it. So innovation happens every day. We are embracing it. And also we have people that are coming from academia, like myself, or the managing director of our team in Greece. So everyone's within this group. At a minimum, they hold 1 bachelor's, 1 master's, and in some cases a PhD too. So we very, very embrace innovation.
Glad to hear that. There's one more question. Could you please tell us some projects or types of projects that you are currently running?
I can think of one that I had the pleasure to participate. It's related to computer vision, and the client, it was one of the largest telco providers in a country, and they didn't have, let's say, clear documentation of where they had their poles installed. So we scanned the full surface of the particular country. We trained image classifiers to pass every single street in order to see whether over there we had poles. And then we saved this, and once we did that for city by city within that country, we returned that back to the client. Andreas, I don't know which project experience you want to share.
Well, for the interest of time, I will not share one particular project, instead stating that we're working across many industries, ranging from high-tech, financial services, product, retail, energy, mining. So within our team, we have many different use cases that are currently being running. Industry-specific, let's say, use cases may differ for sure, but span across different functional areas of expertise, from machine learning, predictive analytics, automation, application development. So someone joining the ATHENS COE, I will have the ability to work in many different use cases and also gain experience in many different industries.
Thank you. Perhaps we can have one final question before we close this very interesting discussion. What is the scale of data that you typically work with? Do you work with many big data sets, or do you have mostly smaller ones and a few big ones? What is the mix?
I'll say it's both cases. It really depends on the industry and how we are set up and what's the agreement that we have with the client. For example, there are cases where financial services institutions will not allow us to export the data through a VPN. So on those cases, we are training ML models in order to create synthetic data, which are purely anonymized. We train our models on synthetic data, and then we return back to our client. We are testing them, assessing them, and deploying them. So I'll say both cases.
Interesting that you're using synthetic data. This is also a very interesting aspect, I think. Have you also, since you cannot move the data, have you also considered federated learning or learning, learning on the edge, or methods that can work locally?
Andreas, you want to answer this one?
100% yes is the question. So again, don't want to repeat myself, but as I previously mentioned, we're trying to be quite flexible and explore all available options that we may have given the timelines that we have ahead of us. With innovation being there always for us, but we may have to make some cutoffs, let's say, on our decisions when it comes to what we would like to explore, given the available time that we have.
And also, we need to be very clever on, those rare cases on how we are selecting the sample cases that we're going to be leveraging.
Okay. Thank you very much. Thank you for the very interesting presentation. I'm sure there will be choices and options for more discussion with some of the people who attended today. And I hope that we'll have the chance to have an update from you in the future.
Would love to have an update, and hopefully that will be one in person.
Yeah, hopefully. Thanks. Have a good day.
Thank you for having us.
Bye to everyone.
Thank you. You too. Bye-bye.